Next, the integration of 1 over x. So when we integrate 1 over x dx, it must be equal to ln x plus c. So this is simple example. Part A, integrate 2 over x dx. Then integrate 1 over 3x dx. So for part A here, okay, first we have to factorize 2, and it is equal to 2 integration of 1 over x dx. And we know that when we integrate 1 over x dx, we're going to have ln x. So our final answer should be 2, the coefficient here. And then the integration of 1 over x is ln x plus c. So that's why our final answer should be 2 ln x plus c. For part B here, when we integrate 1 over 3x dx, first we have to factorize 1 over 3, like this. And then our final answer should be 1 over 3 ln x plus c. Simple. Next, the integration of 1 over ax plus b. When we integrate 1 over ax plus b dx, it must be equal to ln ax plus b over a. Okay, please remember a, because most of students usually forget to write divide by a and then plus c. So this is example. Okay, first we have to factorize 5 outside the integrals. Then we know that when we integrate 1 over 2x plus 3 dx here, we're going to have ln 2x plus 3, and then divided by 2y because 2x here, then plus c. So final answer is 5 over 2 ln 2x plus 3 plus c. Next. Okay, for part B here, okay, when we integrate 3 over 3x minus 1 dx, first we have to factorize 3 outside the integral here, and then it is equal to 3 ln 3x minus 1 over 3 plus c. And then 3 over 3 here will be 1. So ln 3x minus 1 plus c. Next, for example 6 here, we have to find, for part A, the integral of 1 over 5x dx. So here will be, first we have to factorize 1 over 5. It will be like this, and then integrate. So we're going to have 1 over 5 ln x plus c. Simple. Next, for part B here, first we have to factorize 3. So it will be 3, the integral of 1 over 1 minus x dx. Next, it will be 3 ln absolute 1 minus x over the coefficient of x here is a negative 1. So divided by negative 1 plus c. So final answer should be negative 3 ln absolute 1 minus x plus c. So next, for part C here, it must be equal to, okay, the coefficient here is 1, so no need to factorize. So we may write as a ln absolute 2x minus 1 over coefficient of x here is 2. And then divided by 2 plus c. Next, for part D here, this is your homework. I hope you all can solve this question. Next, the integration of exponential function. So the rules is when we integrate exponent x dx, we're gonna have ex plus c. Tips. Okay, salin semua soalan and then divide dengan differentiate power. This one we will discuss after this. Example 7. For part A here, when we integrate 3 exponent x dx, first factorize 3, and then the integral of exponent x dx. And we already discussed that when we integrate exponent x dx, we will have exponent x plus c. So the final answer should be 3 exponent x plus c. Next, for part B here, first, we have to factorize negative 8. So it should be equal to negative 8 integral of exponent x dx. Next, it will be negative 8 exponent x plus c. Simple. Next, the integration of exponential function. When we integrate exponent ax plus b dx, it must be equal to exponent ax plus b and then divided by a, where a here is coefficient of x, and then plus c. So the tips here, we have to copy the question. Means the question is exponent ax plus b. We copy the question exponent ax plus b and then divide by differentiate power. So differentiate power means, okay, the power of ax plus b, when we differentiate, we will have a. So that's why we need to divide by a and then plus c. Example 8. For part A, the integration of exponent 2x dx here is equal to, first we copy e to x and then divide by differentiate the power. The power is 2x. When we differentiate, we're going to have 2 and then plus c. Simple. Next, the integration of exponent 1 minus 5x dx. First, we copy the question. So exponent 1 minus 5x divided by, in this case, when we differentiate 1 minus 5x here, we're going to have negative 5. Then plus c. Simple. Next, example 9. For part A here, when we integrate exponent negative 2x dx, it is equal to, first, we copy the question. So exponent negative 2x over divided by, still remember, the power is negative 2x. When we differentiate, we're going to have negative 2 plus c. Simple. Next, for part B here, okay, first, we have to factorize 5 here, put outside the integral, and then we may integrate this one. It will be 5 bracket, first, copy the question, exponent 3x minus 2 divided by, differentiate the power 3x minus 2, it will be 3. Then plus c. So final answer should be 5 over 3 exponent 3x minus 2 plus c. Okay, next, part C here. So for part C here, this is your homework. I hope you all can do this question. Next, integration of special function. When we integrate f prime x over fx dx, we're gonna have ln fx plus c. So this is simple example. Find the integration of 2 over 2x plus 3 dx for part A. Okay. So we try to assume at denominator side here, 2x plus 3 is fx. when we differentiate fx here, 2x plus 3, we have 2. So 2 here is f prime x. So that's why we may apply this rule, and we will have ln 2x plus 3 plus c, because we apply this rule. Next, for part B here, when we integrate 6x over 3x squared plus 2 dx, first, at denominator side here, 3x squared plus 2, we assume as fx. And then when we differentiate 3x squared plus 2, we will have 6x. So this is f prime x. So still remember, when we integrate something like f prime x over fx, we're going to have ln fx plus c. So our fx here is 3x squared plus 2. So we may write as a ln 3x squared plus 2 plus c. Simple. Next, for the next part here, part C here, when we apply the previous rule, we have to look at first at denominator side. We have to assume that x squared minus 1 here as our fx. And when we differentiate our fx here, x squared minus 1, we're going to have 2x. But in this case, numerator side here, it is x, not 2x. So what we have to do? We have to make it 2x. So just times 2 here, and then divided by 2 or times half as its factor. Next, you already have our numerator side as f prime x. After we apply the previous rule, so we're going to have half the integration of 2x over x squared minus 1 dx is equal to half ln x log of fx plus c, where we know that our fx here is x squared minus 1. Next, for part D here, I will give you an idea where on denominator side here, 3x squared plus 2, you have to let as your fx. And when you differentiate this fx, you're going to have 3x squared plus 2 differentiate with respect to x, you're going to have 6x. But here is 3x. So what you're going to do, you have to multiply by 2. So you need to multiply by 2 times 2. And then you have to divide by 2. You have to divide by 2 or multiply by half. So here it will be half the integration of 6x over 3x squared plus 2 dx. So this one is your homework. Next, okay, this is integration of special function, where you have the integration of f prime x exponent fx dx, and it must be equal to exponent fx plus c. So this is simple example. Okay, for part A here, when you integrate 5 exponent 5x dx here, okay, you have 5 exponent 5x dx is equal to exponent 5x plus c, where when we are trying to compare or refer to this rule, we notice that our fx here is a 5x, right? And then when we differentiate 5x, we will have 5. So this is f prime x, and this one is fx. So that's why when we integrate for our left side here, we're going to have exponent fx. So fx here is 5x. So that's why we will have exponent 5x plus c. Or alternative method, okay, we may factorize 5, put outside the integral symbol, exponent 5x dx, and then will be equal to 5 exponent 5x over 5 plus c, and then simplify, you're going to have also exponent 5x plus c. Part B here, when we integrate 7 exponent 1 plus 7x dx, first we have to assume 1 plus 7x here as our fx. When we differentiate 1 plus 7x, we're going to have 7. So in this case, when we apply the previous rules, we're going to have it is equal to exponent fx. So fx here is 1 plus 7x plus c. Next, for part C here, when we integrate 2 exponent 4x minus 1 dx, as we know here, this is our fx, 4x minus 1. When we differentiate, we're going to have 4. But here it's not 4, it is 2. So that's why we have to multiply by 2. So it will be like this. 2 times 2 exponent 4x minus 1 dx. But since we already multiply by 2 here, we have to divide also by 2 or multiply by half. So it will be half integration of 4 exponent 4x minus 1 dx. And then when you integrate, you're going to have half exponent 4x minus 1 plus c. Or alternative method here, you may also integrate like our previous slide. Okay, in this case, you may factorize 2 outside the symbol of integration. So you will be equal to 2 integration of exponent 4x minus 1 dx. And then it will be 2 exponent 4x minus 1. When we integrate, we're going to have exponent 4x minus 1 divided by 4x minus 1. When we differentiate, we're going to have 4. So divided by 4 plus c. So our answer should be half exponent 4x minus 1 plus c. Okay, next for part D here, this is your homework. So this is your homework. Okay, you may apply between this rule or this rule. It is up to you, as long as you get correct answer and correct solution. Next, when we integrate f prime x bracket fx bracket to power of n dx, it must be equal to bracket fx bracket to power of n plus n over n plus n plus c. So this is example. Okay, find for part A the integration of 3x squared bracket x cubed plus 6 bracket to power of 4 dx. First, okay, we will know that first we have to look at this term first. X cubed plus 6 bracket to power of 4. We know that when we differentiate x cubed plus 6 here, we gonna have 3x squared. So in this case, we may let x cubed plus 6 here as our fx and 3x squared as our f prime x. and 4 here is n. Fx 3x squared as our f prime x. And then after we substitute into this correct formula, we're going to have fx here is x cubed plus 6 bracket to power of n plus 1. So n here is 4, 4 plus 1 is 5, and then divided by n plus 1. n plus 1 also 5. Plus for part B here, the integration of 2x bracket x squared plus 3 bracket to power of 6 dx here. First, we have to assume in this bracket x squared plus 3 as our fx. And 6 here is our n. After we differentiate fx here, x squared plus 3, we will have 2x. So 2x here is our f prime x. Then, after we substitute into correct formula, we're going to have f x bracket to power of m plus 1 over m plus 1 plus c. So here will be bracket fx here is x squared plus 3 bracket, and here is 6. 6 plus 1 is 7 over 7 plus c. Simple. Next, part c here, when we integrate 5 bracket 3 minus 10x bracket to power of 7 dx. In this case, first we have to assume 3 minus 10x here as our fx, 7 here as our n. But when we differentiate fx here, we're going to have negative 10. But here is 5. So we have to manipulate this value. So here will be 5 here. We have to make it as negative 10. So it means we have to multiply by negative 2. So negative 2 times 5, and then bracket 3 minus 10x to power of 7 dx. Since we already multiply by negative 2, in order to get negative 10 here, we also need to divide by negative 2 or multiply by negative half. So here we multiply by negative half, and then it will be negative half, the integration of negative 10 bracket 3 minus 10x bracket to power of 7 dx. And then we substitute into correct formula. So here we have negative half bracket 3 minus 10x bracket to power of 7 plus 1 should be 8 over 8 plus c. So our final answer should be 3 minus 10x bracket to power of 8 over negative 16 plus c. So this is our last example, and I'm giving this one as your homework. But I will give you an idea where you may assume 4x squared plus 4x minus 5 here as your fx. I think that's all for now. Thank you.